All right, so objective 8.3a, today we're working on the transformations of the sine and cosine functions, and our objective is to use the constants a, b, c, and d to perform the basic transformations of the sine and cosine functions. So first you'll notice that I drew a unit circle here with just the quadrantal values. I've also highlighted my cosine values as my x coordinates, or my cosine of theta, and my sine thetas as my y values. This just helps me to quickly graph. I'm not going to be graphing the intermediate values, the pi over 4s. All right, so we're going to start with the sine function here, and since I've highlighted in red, I'll just underline that here in red. And we're just going to zip around the unit circle and graph. So the sine of 0 is 0, so 0, 0. Sine of pi over 2 is 1. Sine of pi, 0. Sine of 3 pi over 2, negative 1. And the sine of 2 pi, 0. And every time we rotate around, then it just starts over, right? It cycles over. So there's the period of your sine function. So we can just continue to copy that same pattern of points on the left side of your graph. Now, when you're drawing your curves, as you're approaching your peaks and valleys, just start to curve your graph. So I'm going to try really hard to do that. It's very hard to do that with this tablet. I missed. I went over the peak. Oops. And then I missed again. You have a little more control because you can actually see what's happening. I'm going to hit it. Oh, I went under. Dang it. Good enough. Okay, so there's my sine function. So I'm going to label it y equals sine of x. And I'm just going to note that the period of my sine function is 2 pi, because every 2 pi the cycle begins over and you get a copy of the same set of points. All right. It also has an amplitude of, from the midline to the peak, of 1. Okay. All right. Now I'll go to the cosine function. So I'm going to switch to blue now. And I'm going to look at my highlighted values on my unit circle. So the cosine of 0 is 1. The cosine of pi over 2 is 0. Pi is negative 1. Cosine of 3 pi over 2 is 0. And then back to 2 pi, we're back up at 1. And so you can see that pattern of points over 2 pi, 1 full revolution. So we'll just repeat that pattern. Repeat that cycle. And draw your sine function. Or your cosine function. So you can see that cosine is always just beating sine by pi over 2. It hits the peaks first. It hits the valleys first. And so it is the leading function, where sine is your lagging function. It's always behind by pi over 2. All right. And so there's y equals cosine x. So these are our parent functions of our sine and cosine graph. And so this will be our reference. These are our reference graphs. So when we do our transformations, we'll start with just a little sketch of these in a dashed line, and then we'll perform some transformations. Let's talk about the amplitude of cosine. Midline to peak is a distance of 1, and the period for a repeat is 2 pi. So they have the same amplitude, the same period. This is information that you can put on your index card, by the way. All right, so let's take a look at the variations. So when you add in numbers a, b, c, and d, you transform the parent functions accordingly. And let me tell you something. It's not any different than if we were working on a quadratic function. Okay, so one thing I do want to mention, though, and I'm going to grab my pencil here. Maybe I'm going to grab my pencil. I don't have a pencil. So I'm just going to grab my black pen here. If I have bx minus c, both terms and both of my horizontal actions together, you do want to do a little factoring out of your b term so that you can see your horizontal shift. When you have a b and c term, it affects your horizontal shift. So we would rewrite this as y equals A sign, and I'm going to put a bracket here. We're going to factor the B out. So if I divide the B out of bx minus c, well, bx divided by b is x, and c divided by b is c over b. So we'll factor that b out, so you can see that your horizontal shift is your c over b plus d. Same thing if it was, of course, the cosine function. You know they have a lot of stuff in common. So if there's a b and a c term, factor the b term out by dividing it out of both your first term and your second term. Okay, so color coding here. So I'm trying to remember how I'm color coding tomorrow so that we can do this in the same order. Let me check my notes really quick. Should pause the video, but you're just going to live with it. Okay. Just so that we're consistent from day to day, because I think consistency is good. So we're going to do A in blue, B in red. So A blue, B red. I should have done B blue, huh? Yeah. Oh, well. A blue. So A represents your vertical action, right? Because it's definitely outside the parentheses, so it's vertical. So that means it affects your y coordinate, right? So if it's A is greater than 1, you know you're stretching your graph, right? So if A is greater than 1, it's a stretch. So you just do A times your y coordinate. And if A is less than 1, then it's a compression, right? Right? Yes. If it's a fraction, it's a compression. And so that would be y divided by A. Okay? And then, of course, if A is negative, so if A is negative, so a negative A just means you're going to do a vertical flip. So just remember that. Also, in terms of trig, the absolute value of A is your amplitude. So start learning. A is amplitude. Okay? Switching to B. So I'm going to red now. B. Your B term is inside your parentheses. So your B term is your horizontal stretches and compressions. So remember, if your B term is greater than 1, what is that? It's a compression. Remember, you have to go opposite. So you're going to do your x divided by b, right? And if your b term is less than 1, it's a stretch. Well, okay, so I'll put absolute values on them, and then we're good. So we'll put absolute values on those. You could do the same thing over here. We'll put some absolute values on those. Okay, so absolute value. So that's a stretch of b times x. Remember, you just do the opposite of what it says. And if it's a negative b, you're wrong, but you're close. Negative b is a horizontal flip. Okay, so also, the period of the sine and cosine function is 2 pi. So if you divide that by the absolute value of p, b, you get the period. Okay, so the period is 2 pi, which is a normal period, divided by your b absolute value of your b term. Okay, all right, switching to green. All right, so c over b. Now, sometimes it's just c because your b is 1, or sometimes you have to factor and it's c over b. It's always c over b. Okay, c over b is your horizontal. Oh, that is a fat pen. Let me back that up and see if I can't get a skinnier pen going on here. Let's try this again. Horizontal, that's better. So this is your horizontal shift, right? So if it says negative c over b, that means we go to the right, c over b. And if it says plus c over b, that means we go left, c over b. So remember that. Okay, then also, the opposite, I'm just going to write opposite of c over b when we're talking about trig functions is called a phase shift. Okay, so you need to change your language from horizontal shift to phase shift. One full period, if you shift it to the left or right, you're changing its phase, or you're shifting its phase. Okay, D term. D term, that's this one out here. What's that? Represents vertical shift, right? So if it says plus D, you go up D. If it says minus D, you go down D. Also, the midline equation is y equals D. So that'll shift your graph, the midline, up and down. Okay, that's a pretty useful tip. All right, so now that we have all of that, we are going to start with the simplest of the transformations. Okay, I don't know what that's about, but whatever. Okay, so first let's just note that we're looking at the sine function. Okay, so we're going to sketch a graph of y equals sine of x plus 3. We're going to label the midline, identify the range. So I'm going to start with just the parent function of the sine function. So that starts 0, 0, then it cycles up, and then back to 0, cycles down. And you'll notice that I was kind of thoughtful about creating my graph. You see that the graph that I have goes up to 4. You think I did that on purpose? You know I did. So I'm just going to do a little dash line because this is not really what we're supposed to be graphing. Of course, it's just a reference graph. It's the graph that we will be shifting. So that's the graph of y equals sine of x with a midline here at, just going to draw that in there, try to attempt to do that, y equals 0. There's our midline. Okay, so there's our graph. Now, if we look here at our equation, it says y equals sine of x plus 3. Now, I know that that's a D term and not a C term because it's not in parentheses with the x, so it's definitely a vertical action. So the first thing I'm going to do is identify the midline. Remember what the midline is? It's y equals D, and D is 3. So I'm going to grab my green graph, no, black graph. We're doing black here because that was the color of our D. I wish I had my pencil color. I'll have to load it to my, I've been using my iPad all day, so it's really hard to switch back to my tablet here. Okay, so that's y equals 3. And all we're doing now is just taking all of our points and pushing them up 3. So we regraph our function. I don't think that this is that difficult of a concept since we practiced so many transformations in the past couple of years, right? Oh man, I need to get a new stylus. I've used it for so many years that the little tip of my pen has rubbed down to nothing. All right, and there we have the graph of y equals the sine of x plus 3. So what's the range? That's the last thing we have to do. Yep, maximum, a minimum to maximum. Closed interval from -2 to 4. Okay, ready? So that was the easiest transformation, right? Shifting up and down, that's the easiest one. Okay, so now let's move on. Okay, so example 2. And I do have a little typo here. Yours says to do the second one in black, so I'm just going to change that to say black. All right, so here we have example 2. Sketch the graph of y equals 2 cosine x in red. What's the amplitude? What's the range? And I'm going to do that one with you. And then I'm going to press pause, and I'm going to have you graph y equals -½ cosine x in black and find the amplitude and the range. All right, So let's start off by making sure we're identifying the fact that this is that is not what I wanted. I wanted a highlighter. Cosine function. Cosine function. Okay, so let's start by graphing that. Okay, so cosine starts up high, 0, 1, and then it cascades down on both sides. I'm just going to label that parent function y equals cosine x. And since I don't have any vertical like shifts going on, I'm not going to label the midline. I don't really need to do that. All right. Now, I'm going to grab my red pen. Oops. And I'm going to look at my first function. Now, no, did I do A in blue? I did, but that doesn't matter. It says to do it in red, so I'm doing it in red. So my A term in this case is 2, right? So that's a vertical compression or stretch. So that's a vertical stretch, right? So we're going to take all of our y terms. So we're going to do 2 times all our y values, right? So I'm just going to start right here at negative 2 pi 1, and I'm going to multiply 1 times 2. And then at negative 3 pi over 2, 0, 0 times 2 is 0. And at negative pi negative 1, negative 1 times 2 is negative 2. So you see the vertical stretch happening there. So 0, 0, the 1 goes to 2, 0 stays at 0, and the negative 1 goes to negative 2. And you stretch your graph. And there you have it. Remember, it's vertical, so you apply it to the y coordinate, not the x. And then just when you're doing your curves, you got to just start thinking as you're approaching your maximum, start to curve before you get there. That is awful. I'm going to do that again. So I think I'm going to start down here. I challenge you to come do this on what I'm using.
So for this, what we put A, I label A, so A, B, C, D.
Yeah, your 2 is A, right? Oh yeah, this is A, right? Sketch the graph, but I'm also going to label it y equals 2 cosine x. All right, B, what's the amplitude? So remember, the amplitude is the absolute value of the A term, so the absolute value of 2 is 2. And you can really see it because from the midline to the peak, it's a distance of 2. Okay, what's the range? Negative 2 minimum to positive 2 maximum. All right, so I'm going to press pause. You press pause. Do D by yourself, and then when you've got D done, come back and let's see how you did. Okay, so for your second graph, you had a vertical compression of negative 1/2. So you're multiplying all your y coordinates times negative 1/2. That was a vertical flip and compress, right? And so you can see my really flat cosine function there that's been flipped over with an amplitude of 1/2 and a range from negative 1/2 to 1/2. All right, now the hard one. Okay, so I'm going to try to make it better for you. So it says sketch a graph of y equals sine of 4x. Okay, so what term is that? Yeah, it's a horizontal action, right? And it is a compression. So we remember that when our B term, it's our B term, right? So we're going to take all of our x coordinates and divide them by 4. But let me see if I can simplify this for you. So let's find the period first. Because remember that a period sine function just goes from 0 and then to 2 pi, it does that. So that's a period of the sine function. So let's find a period if we divide it into 4, right? So we're going to do 2 pi divided by the absolute value of 4, or 2 pi over 4, which is 1/2 pi. So that means from 0 to pi over 2, we're going to get a full sine function from 0 to pi over 2. And I think that would be useful instead of trying to do your compression in another way. So we know we're going to compress, right? Horizontally, so that's a horizontal compression. We're doing our x coordinates divided by 4. So we're compressing our period from 2 pi to 1/4 of 2 pi, which is just pi over 2. So we're going to start here and finish here. So there's the halfway mark with one peak and one valley. And so there's a full sine wave right there in a period of 0 to 2 pi. Do you see that? And since there aren't any phase shifts, we don't have to worry about that being in the wrong position. Now, do you need me to draw the original function? Or are you good? Good. All right. Then we're just going to go ahead and draw. Wait, that's supposed to be, I missed a point there. Hey, I went back a page. I meant to go back a button, and I went back a page. Oops. I think I will go ahead and draw the original function just so you can see the compression. So I'm going to go ahead and do the original function as well. So I just did one sine wave of the parent function, and then I'm having a hard time with my compressed function here, but you can see how compressed it got, right? Because you're going to do one full cycle of the sine function over a distance of 2 pi, or pi over 2. I hope yours looks better than mine. Okay, do you see it? Yes or no? Yes? You see the compression? So we'll just go ahead and finish that out. Oh, I keep hitting those points. Shh. Guys, you're on video. Zip it. I don't particularly enjoy compressions horizontally. And I would say that often when I have to do a compression of a trig function, I will use my calculator. Well, if my compression is not like over a value of pi over 4 or pi over 2, if my compression is some other value, then I will get my graphing calculator out to do the compression, because it's just not convenient to try to do it on my own. All right, so there you have it. So you can see that black, I drew it back here in black, that's the original sine function. And I think something that's important to note here is that you can see from, I'm going to just do one of these in black here. So you can see one full sine wave over this distance of pi over 2. And then you see another sine wave. And then you see another sine wave. And over 2 pi, look how many cycles of the sine function you have. You have 4 of them, because you compressed it to 1/4 so that you could fit 4 into the original sine function's wave. And so there's that. All right, last one. So here we have, I'm going to green here, sketch a graph of y equals the cosine of x minus pi over 2. So listen, you do have a b term, but your b term is 1. Okay, so we don't have to factor it out. So the question here is, what is the phase shift? And we are working on the cosine function. I'm just going to underline it because I'm having so much trouble with my highlighters. So we're going to work on the cosine function. So let's go ahead and graph it. Remember, it starts up at a 0, 1, and then hits the 0, and then the -1, and the 0, and the 1. And it really is pretty good to take when you're doing shifts, and this is a horizontal shift, to have your parent function sketched out so that you can shift those points left or right. So we have our cosine function there, y equals cosine x, and we have a shift. And our shift here says we're going to push the graph to the right, pi over 2. So that's a horizontal shift. So all of our points are going to go right, pi over 2. So this one up here at the peak goes to the right. This one down here at the valley goes to the right. And then I'm just going to move all of my peaks and valleys first, and then I'll move all my zeros, which will be in between. And I've just shifted all of my points. And now I look like, I think I'm graphing my sine function. What do you think? Yeah, because the sine function lags behind the cosine function by pi over 2. And so what I just did was I graphed my sine function. So here's y equals the cosine of x minus pi over 2. So here's your horizontal shift. But when trig, we don't call it a horizontal shift. We call it a phase shift. So remember, phase shift is the opposite of c. So that would be a positive pi over 2 over b. So our phase shift is pi over 2. So tonight in your homework, you're going to do on 8.3a, problems 1 through 17 odd. And if you do 2 through 18 even, you can double your score, but you have to do them all. Make sure when you draw your graphs, I really am okay with you just doing the quarter marks, but make sure you label your axes. And most of the graphs will just be 1 or 2 transformations. And so here's my advice. If you have to do multiple transformations, transform B, then A, then C over B, and then D. So that should be the order, if you have more than one to do, that you should perform your transformations.